Hello, everybody. Thank you for joining our webinar today. My name is Mersh. I am an advisor at Katalon and also the VP of Testing Services at KMS Technology. And I'm happy to be presenting our webinar today titled Software Testing Trends for 2019. A chance really for us to share how to stay ahead of the game as testers. Co-presenting with me today is Virendra Singh, who is also the technology head and co-founder at Tools QA.
Hi everyone, this is Virendra Singh.
So the agenda today is to talk about the key testing trends that are tied with continuous delivery. I have specifically sort of identified continuous delivery as the key medium of discussion today, just because I feel very strongly, as I'm sure most of you have seen as well, that everything that we are doing as testers revolves around being able to deliver effectively, quickly, and with high quality in all of our engagements and projects. So the key trends that are tied to continuous delivery will be discussed and identified today. And then Virendra will be talking a little bit about the distributed architecture and how to perform API testing using Katalon Studio. And then we will close this off with any Q&As that the participants can post in the Q&A section of Zoom. So starting with the key topics, as I was alluding to earlier, a lot of discussion always revolves around the use of the term continuous delivery or continuous deployment. And people in my observations use that quite exchangeably and imply to say that delivery and deployment are the same. But I have identified a very good definition to sort of give us the difference between the two terms. And this is a quote that I have identified from a person called Martin Fowler, who has his own website and has been able to put this in the most concise way for clear understanding. What he mentions is continuous delivery is all about keeping your application in a state that it is always able to be deployed into production. The difference between delivery basically and deployment is the fact that deployment means you are actually deploying every change into production as frequently as needed. So deployment is more about just getting the change into production versus delivery being keeping the application in a state where it can be deployed on demand. The key difference there again, I believe, is everybody's targeting to keep their application in the first use of the word, which is delivery rather than deployment. What that means for us as testers, right, is automate essentially everything. When I say everything, it's not just testing, but the process of building the application, the ability to create the infrastructure, the ability to deploy it, and then combine testing in pre-production as well as testing in production. Automate to the maximum, automate as much as possible, ideally automate everything. Here is a few quotes that I wanted to just share with everyone on this presentation that has been identified or observed as part of the continuous delivery cycle. For those of you who are familiar with the World Quality Report, this is a report that has been coming out for us in the testing industry for the last 10 years. And the most recent one came out around October or November of last year. What they found was that 99% of the people who responded to that survey indicated that they were using DevOps in at least some of their projects. This compared to prior trends is definitely very, very high. And as this sort of amplifies or confirms the trend that the industry is moving towards with continuous delivery, which is how can you use the automation of everything, essentially from deployments and so forth, as part of the DevOps tool chain to be able to deliver with high speed. Another survey / report called the State of DevOps from 2018, which was again released late last year, indicated some very interesting information. Almost half of the teams that were reviewed indicated that they deploy between once per hour and once per day. Just step back and think of what that means, right? You essentially have code going into production as often as once per hour and as slow as once per day, which is very different than what we've traditionally seen before, which is anywhere between once a month, once every 2 weeks, once in 6 months, and so forth. Also, half of the teams typically go from code commit to production between 1 day and 1 week. Again, a phenomenal change in the logistics of how often code is moving into production. Another sort of survey from Forrester also identified that almost 3/4 of everybody who was reviewed or talked to indicated and confirmed that testers are critical to their continuous delivery success. So, the general feeling that most people have is with automation and a lot of tools coming into play, will testers become obsolete or a commodity essentially that is no longer required? And what this confirms for us is our roles are secure. We're not going anywhere, but it is important that we adapt and adopt to the tools and the processes, which helps the teams deliver with high speed and high confidence. And then finally, one of the surveys that we at KMS Technology also did was to find out more about the impacts that continuous testing in this continuous delivery model has. And what we found was almost every team that we talked to has identified that they have seen great benefits from implementing continuous testing as part of the continuous delivery pipeline. And what they have found is testing in that fashion definitely enables them to achieve a high sense of confidence in the software that has been released, and they are able to get much faster feedback on any defects that may have creeped into the application. So, here's some of the data that the industry is definitely talking about and realizing the benefits they are getting with continuous delivery. So keeping that in mind, I'm going to walk through the 5 trends that I believe will become key and be critical in 2019. In no particular order, I'm going to start with something that I believe is key to the success of continuous delivery and also enables testers to be an integral part of the team. So the first trend is essentially you should be seeing a lot of testing shift left and involve a lot of developers. So shift left essentially means interacting and getting testing done sooner, as well as partnering with developers to help support the testing activity. The way you do this is you obviously leverage a lot of tools, right? And that's why automation tools become a critical part in this particular trend. And automation tools should be added to the developer's toolkit to enable us as testers integrate much tightly with the development team. What this means for us as testers is you have to encourage and foster the culture of your team, so that way the testers are in sync, not just with the developers, but with the product owners as soon as possible. And this means if there's a particular user story that's being developed or talked about, how can you adopt and become a contributor to discussing that and supporting the evolution of that idea? How can developers implement that idea in code? What would be some of your recommendations of things that developers should keep in mind as they are writing code to support those user stories? So the process and the culture of integrating yourself with the rest of the team as early as possible is definitely something that will help you adopt this particular trend very effectively. In terms of process, what my recommendation would be is, as you are building a testing strategy, uh, incorporate ideas that enables developers and testers to share the test coverage. What I mean by that is, traditionally developers are focused more on a unit test perspective and leverage tools to do that. What you should encourage is, how can you understand what is the scope of unit testing that is being done? What can the developers help test more using your automation tools? So that way you are eliminating any redundancy and essentially being able to come up with a solution for testing that offers more coverage. In terms of tools, my recommendation to be able to successfully leverage the shift left movement of testing would be to adopt tools that help automate the testing of components, integration testing, UI tests, all of this being done as part of your CI/CD pipeline. So if you're using tools such as Jenkins or Bamboo to do automated builds, leverage tools that can work well and integrate well with those tools. So that way automated tools testing can be kicked off as soon as possible. The second trend that I feel very strongly will continue to become mainstream and grow a lot in 2019 is going to be a wider use of containers and environment orchestration. So what this means is, instead of having to rely on real infrastructure environments where somebody within your operations team is actually managing the environment for you, using tools such as Docker, using tools such as Kubernetes, using tools such as Puppet to help the testers be more independent and be able to create infrastructure on demand is going to definitely grow more and more. One of the quotes that I did see, which I feel aligns with what most of the good leading tools are doing or teams are doing, is from a quote I saw on DZone, where it was mentioned as part of the survey that was done that roughly half of the developers that were polled were using container technology. And it's interesting that there was no mention of testers doing that. So one of the things that I highly recommend and also see great benefits of doing is, when testers begin using containers and orchestration, they not only integrate more with the developers, but they also reap a lot of benefits that those tools offer in terms of saving time when you are retesting defects or trying to build up environments where you have isolation using specific test data and so forth. From a process perspective, what I recommend as members adopt this is, you build out a test strategy that leverages the creation of consistent test data. One of the things that containers help you do a lot with is the effective management of that test data that you could use as part of your testing. And it's also very efficient in offering the time saving as far as retesting of defects that have been observed and reported. Accessing logs specific to environments is also something as a big benefit that would come out. And then finally, because of orchestration, a lot of deployments and scaling needs are easily addressed. As far as tools go for this particular trend, what I would recommend is testers become familiar with tools such as Docker and Kubernetes. Essentially, these tools that allow us as testers to deploy and spin up environments, more and more in the cloud infrastructure on demand. So definitely something that is gaining a lot of momentum just based on the benefits that can be gotten for testers. The third essentially trend that I have also seen is there's definitely going to be better and more test coverage and run analytics that would be done with machine learning investments and tools. So essentially what is happening now is a lot of tools focused around supporting testing activities are coming up that are leveraging machine learning algorithms and AI technology. That's something that will definitely continue to grow this year as well. So as testers, we definitely need to plan in using that as part of our testing strategy. The use of machine learning in testing, especially around predicting what areas to test based on high risk, right? Whether it is a combination of a certain developer working on a certain feature that traditionally indicates defects to arise, or whether it is areas of code that have changed as you build out machine learning algorithms and models that help you predict that more. That would be something that testers would definitely be benefiting from a lot. And the capabilities of such tools is going to be on the increase this year. From a tester's perspective, I would say we would need to make sure that we understand, what are the different machine learning algorithms that exist out there? What are the different algorithms that we need to use in order to define models that help us analyze data to be able to provide maximum impact, right? And the way to focus on that would be, could you use data such as the different defects that have been observed in the different features or functional areas of the product that you are testing? Is there a way to get some prediction areas done by saying, like I was giving the example earlier about the combination of a certain developer working on a certain feature that may give a certain risk factor of new defects being introduced. So you could be doing a lot of tools out there help build that and help you train models on your data. So getting familiar with that would definitely be something that I would do to start leveraging this. In addition to that, from a process perspective, we need to always look at evolving our testing strategy to start leveraging this predictive analytics. Because insights that AI would be able to generate for us would essentially allow us to point out any gaps that may exist in our preconceived test coverage. It just acts as another recommendation for us as testers to use to go back and then test based on the recommendations coming out of those algorithms. And then as far as familiarity with tools, I think a lot of the machine learning tools that are out there now, essentially they will enable testers to give more coverage. One of the things that always I get asked about a lot of times is if I feel that AI will essentially replace testers. My personal opinion is it's not something that will actually replace testers. It is something that will enable us to be more effective and efficient. So just another alternate to an automation tool, right? It's not something that replaces testers necessarily, but it helps us evolve into a bigger role and enables us to do better testing. Trend number 4 is going to be exploratory testing in production. So for those who are not familiar with exploratory testing, this is a slightly different type of testing compared to the manual step-by-step instructions, which are typically called test cases. I'm sure a lot of you see those in your day-to-day activities. But exploratory testing essentially gives you the tester the full control of how you achieve the results you are trying to seek. So, for example, once you understand what a user story is expected to do, you as the tester are in control of identifying how you achieve that user story. Versus giving you a detailed step-by-step instruction. And what that essentially does is it allows you to find, you know, observe defects much more effectively, much more quickly. However, with the concept of continuous delivery where everything is automated, that would be one direct impact where exploratory testing done by my testers would be done in production. This is something that is happening now, especially with the teams that have implemented continuous delivery effectively in their team, where they go into production and maybe in a certain isolated area of their infrastructure are doing exploratory testing directly in production. So that's something that will definitely grow more as more and more teams start doing continuous delivery. From a people perspective, I would say that the skills around automation are definitely something that would continue to be required for testers to learn and be better with. Automation will continue supporting this concept of checking, right? While exploratory testing will focus on allowing us as testers to bring more value and focus on business assurance type tests. Finally, from a process perspective, right? The one key thing we have to make sure we do is we expand our testing strategies to allow business assurance in pre-production and production to come into play, especially because CI/CD practices are going to become mainstream. And then from a tools perspective, any tools that help you record your user interactions as you are performing your exploratory testing would be something that I would want to identify, just because I could then use that as a way of identifying automation candidates that can help me expand my automation test coverage. Finally, trend number 5, which I think is one of the biggest moves that will occur, is the continued accelerated demand or need for automated testing of APIs. One of the things I was able to identify as part of the annual State of API Integration report that came out late last year was the quote that I have on this slide. What I wanted to share with the audience today was that not only have APIs become a necessity for application customers to streamline operations, right, across their entire business and product suites, they have also become an integral part of product development and business strategy. So as you guys are probably already familiar, with a lot of interactions across different applications, APIs are the foundation building blocks for that. In addition, those applications that are built using the microservices architecture, APIs form the backbone of those applications as well. So us as testers being able to effectively test that with high speed requires a specific strategy of testing APIs and then leveraging tools such as Katalon to support that testing. So it's definitely something I believe is going to be the biggest chunk of growth for this year and well into next year. And I think it's very important for us as testers to get ourselves very familiar with this type of testing. From a process perspective, what I would recommend is, API testing starts being done as early as possible. So it actually even supports the shift left mentality, the first trend I was talking about earlier. And then it also enables the entire team to adopt and integrate well, and developers can be leveraged in helping support this testing as well. From the tools perspective, using the right tools, obviously, just like any other ones would make sense. Any tool that allows API testing to be done, in a straightforward fashion, and allowing you to use APIs to also do more effective test data creation and management is something that I would look for as an option as part of my strategy, as well as the capability of tools. So those are the top 5 trends I believe that will become mainstream in 2019 and beyond. At this important juncture, I would want to hand over the microphone to my friend Virendra to talk a little bit about distributed architecture and API testing.
Thank you very much, Mash. It was such a nice presentation from your side. And thank you for letting us know about these trends. Uh, Taking forward from here, there was this last point that Mash has mentioned about the API testing. Now, API testing is becoming really very important because more and more systems are moving towards a distributed architecture. In a distributed architecture, web services basically play a very important role. Uh, and this is kind of the future. In a distributed architecture, the application complexity is divided into multiple components, and each component has a single responsibility of performing a task in the overall application feature. So let us talk about REST APIs and APIs in general, and let us see how how we can test APIs using Katalon. So in this session, I will try to cover up a basic understanding of distributed applications. Then we will talk about what a distributed architecture looks like, and then we will understand what are the benefits of having distributed architecture. And at the end, we will try to understand what APIs are and what API testing is all about. We will also take a look at how Katalon Studio can help us achieve API testing in a very efficient and fruitful way. So let me start with it. Can someone help me with moving the slide one step backwards? Thank you very much. So let us start with what distributed architecture is all about. So as the application grows complex, it becomes necessary that we divide the application into components, and each component playing a specific role in the overall application. And these components, they can live maybe on the same network, or they can live on different networks across geographical boundaries. So these components, they can interact with each other using technologies like HTTP communication model, or maybe some other model that suits that particular need. But the important point here is that the components can talk to each other, and they can ask the other, one component can ask the other component to perform a task, and then at the end get a result back from that component. It might be a little confusing at this point, but let us look at the diagram in the next slide, which can help us visualize this problem. So every one of us might have gone through an e-commerce website. So whenever you open your URL of any of your favorite e-commerce website, it actually presents you with a lot of information. Information like product, your personal details, the products that you have looked for, and the analysis of your past behavior and the kind of products that you might be interested in. Now, these are like quite a lot of different tasks that uh, that an application has to perform as soon as you open it. In this case, your e-commerce website. So in this diagram, on the left hand side, it's the user who's trying to access a web application, let's say amazon.com. And this amazon.com application, the front end part lives on a web server. Now this whenever a hit comes to this web server communicates with different components, which are shown on the right hand side. So the components could be the payment and billing server, the product inventory server, and the analytics server. So while serving information to you, a web server can communicate with these three different components and get information so that it can present it to you. Now, this is a distributed architecture. In this case, the application, which is the web server, it lives separately from the payment server, product inventory server, and the analytical server. So all of these components, they interact with each other, but they are distributed in nature. Now, having a distributed architecture has a lot of benefits. A lot of benefits. We will take a look at it in the next slide. So distributed architecture, can we move on to the next slide, please? Yeah. So whenever an application creates a distributed architecture or follows a distributed architecture pattern, then it reduces the complexity per component, in the sense that now each component is responsible for its own task. So it can be less complex as compared to the overall application. Then there is a programming language independence per component, in the sense that every component can be built uh, on a different technology altogether. The only requirement would be that all the components, they can interact with each other, and as they interact using mostly using HTTP protocol, so uh, they are able to be they are able to express themselves in different programming languages. Still, they are able to communicate with each other. And then the third very important advantage is the reduced load per component. So if there are different components, then each component has a specific task, and the request for that specific task comes to that component. So it will be spared from unnecessary requests. For example, loading a UI, maybe whenever a user hits a URL. So this is how a distributed architecture can help you have a better application, a more robust and reliable application. Now these components, we have given them a name component, but these are basically services. So if we can go back to our visualization slide. Yeah. So in this case, we can consider payment and billing as a service, product inventory as a service, and analytics as a service. So these components, they behave as a service, and someone, in this case, the application server, it can call these components and request for information. Now, with this distributed model, it is also possible that a test team can interact with these components and get the information. The only requirement is that these components, they express themselves in a particular format, in a particular standard, and that is what an API is. So whenever a component or a service wants to express itself as a set of contract, a set of methods, and with a fixed set of input and output, then it becomes an API. Let us move on to the API slide, which might be the third slide from here. Yeah. So we all have heard this term API. We all have heard it in different contexts. In the context of a distributed architecture, API is basically a pseudonym for web services. API, the acronym stands for Application Programming Interface. And API basically defines a contract between the component and the user of a component. So a user of a component can communicate with a component using this API surface. And it has to be a strict format, in the sense that there is a strict data that would be expected from the consumer, and there would be a strict data that would be returned to a consumer. So API is that definition. So it defines how you can interact with a component. And that brings us to a very important point, that if you have a system, a distributed system, which has an API exposed, then how can you leverage those APIs and test your application even before any GUI has been created or has been developed by your team? Moving on to the next slide. In a typical application infrastructure, or in a typical application layering, if you look at the layering of application, you would find multiple layers. At the bottom, we have a database layer where all the data is stored, which is the data store. And just above it, there is a business layer, which is your backend logic. This is where all of your business logic lives. And just above the business logic, you have your presentation layer, which is basically the UI. It could be a it could be a web page, it could be a mobile application, or it could be anything that you desire. So UI, the presentation layer, is basically targeted towards the user. A user uses a presentation layer, and the presentation layer internally talks to the business layer. Now, business layer and presentation layer, they talk in terms of APIs. So now you can access the API using your presentation layer, or you can write specific tests which can directly access the web API uh, to directly test your business logic. So the core of your logic can be tested directly using the APIs. So you don't have to wait for the presentation layer, in this case, your UI layer, to come in order to test your application, which gives you a tactical advantage that you can test your product uh, before, like early in your product development lifecycle. As we all know that as when we test, the early we test, the more we save, and the later we test, the more we spend. So it is better that you test early in the life cycle of your development. Now, moving on to the next slide. Apart from just testing your application at a layer above your presentation layer and testing it early, there are other benefits of API testing also. For example, API testing is faster than UI testing, in the sense that uh, when you directly communicate with an API, you basically are making an HTTP call to this to your API server, and you are getting raw information, which could be a JSON packet or an XML packet, right? So you can verify your JSON object, you can verify the internals of your JSON response that you get back. You don't have to render a UI, you don't have to create a UI. So communicating with an API is faster as compared to when you communicate with the presentation layer, which is basically the UI. So you get faster tests. Now, API testing is more reliable. It is reliable as compared to the UI tests, because in this case you don't have to deal with the UI, uh, which is historically flaky in nature, in the sense that whenever let's say you open a web page, you might expect a button to come, but then the button takes a little more time to come as expected, and your test fails, right? So an API test is more reliable from a presentation layer test, because it doesn't have to wait for any UI to appear on the screen. It can directly hit a web API, get the data, and perform its test. Now, there is another advantage, uh, which is basically we talked about earlier. APIs are generally available earlier in the project development lifecycle. So you can consider it as a forking point at which uh, your development team will create your API standards, they will create your API definitions, and then there would be another team that will create your GUI, the presentation layer. And at this point, the two teams may separate once the API definitions are properly created. These teams might separate and they can develop individually, but uh, it might take more time for your presentation layer to come up. But API layer would be present before your presentation layer. At least you would have your API definitions, which means that you would know what kind of data you have to send and what kind of data you will receive. So you can write tests based on that, and you don't have to worry about the UI. Moving on to the next slide. Now, we talked about benefits of API testing, and we saw that there is a real need of learning APIs. And as a tester, there is a real need of learning APIs and um, and understanding technologies that can help you test APIs in efficient way. There are a lot of technologies that are available right now. For example, Postman, Rest Assured. These are the kind of tools that you already have in the market, which you can use to test your APIs. Uh, but Katalon Studio has a little more advantage as compared to these tools, because Katalon provides you with two main interfaces. The first one is that you can write your code if you are a technical person. For example, if you are an automated tester, you can write your code directly. Or if you are a manual tester and you want to contribute in your automated test, then it has a GUI interface, which can let you interact with UI elements and create your test. So you don't exactly have to write code. you have to basically just create statements which will internally generate code for you. We will take a look at all of this in a minute. So here we will see in this part of the presentation, we will see how we can create an API project and how we can create an API request object, and then how we can create tests around those request object, add a few assertions here and there, and then create a test suite after at the end, and then run the test. So here we will see how actually a Katalon Studio will help you write tests. Uh, I think we can move on to the next slide, but I have to pull out Katalon and I will move from the slides. So I will have to share my desktop. Is there any possibility to do that? All right.
Hi,
So
Virendra. Yeah, let me make you presenter, uh, and then you can share your screen.
sure. All right. So is my screen available?
Yep, we are seeing your screen right now.
All right. So here is a small test that I already created, but I think we have a little time left. So let us do it from the start. Let me just move it here. Um, we will create a new project, it seems. So let me just close everything out. All right. So on the left hand side, we will just delete this project. All right. All right. So this is the UI that you get basically when you open a Katalon Studio, and this is the home page that you get. On the left hand side, there are sections for tutorials, FAQs, and user guide. You can just take a look around and understand more about Katalon Studio. But the starting point for you would be file, create a new project, something similar to a standard IDE that you might have used earlier. So you create a new project. When you create a new project, it gives you an option to name your project, of course. So we would say that bookstore API. I will talk about what bookstore API is in a minute. And then it gives you two options. Either you create a generic project or you create an API or a slash web service project. So here, a generic project is basically a project where you would test your mobile applications, web applications. It will give you all the contextual information or all the keywords which are related to those types of projects. On the right hand side, we have an API project. So we will select an API project. You can add a description for later references, and then you can click on OK. So once you click on OK, it will create a project for you, a project template, and it will give you a quick starter guide. You can take a look at it on your own. By the way, Katalon Studio is free to use. You can download it and you can use it freely. All you have to do is just register yourself. So you can take a look at the quick starter guide. But the important point here is that on the left hand side, uh, you can see that a project structure is already created in the test explorer. So this project structure is basically uh, if you have already done automated if you have already written an automation framework, you would understand that the left hand structure that you see in the test explorer is basically the kind of framework that you create. So a framework would have a test listener. So you already have this section here. You will have some kind of an object repository. So Katalon will automatically give you an object repository. You will have the facility to create test suites, data files, checkpoints, and keywords. So all these facilities are like by default created for you. All you have to do is just use them. So this is one way where you can accelerate your development time. So you don't have to basically spend time in creating the bare backbone of your framework. All the boilerplate code, you already have it in Katalon. So the idea here is that wherever you create a new project, the very first thing you do is you create object repositories. You create objects in the object repository. So an object is basically uh, a reference to your some entity in your application. So when you are testing a web application, it could be edit control. For example, a first name edit control, a email ID edit control, or maybe your username edit control. So you have to create objects which will map to real-time objects in your application. So in this case, as we are creating an API project, it won't be a web object, it would be a simple web service request. So I will create an object, I will right click on the object repository, and I will do new web service request. So once you click on the web service request, it will ask you to give a name to a web service request. So here we will simply say that I want to test an API, which is a get all books API. And then all you have to do is just give the URL to your request, but I will just try to ignore it for the moment, and I will click on OK. So once you click on OK, you will see that an object is created. Now this object here on the left hand side, which is get all books, it basically represents a web API request. You can configure the web API request from the right hand side module that you see on the right hand side where my mouse cursor is moving right now. This is the module where you can modify your API request. For example, you can specify what kind of request this is. Is it a get post, any HTTP method type that you want to use for your request based on your API contract, and then you can enter the URL of your web method. So in this case, I have just copied the URL, which is the bookstore URL. It is a sample API that we have created for our students, and our students on Tools QA, they can come here and learn more about uh, the APIs. We'll talk about it for a brief moment if we are left with some time. So all you have to do is just enter the URL. It is a simple GET request. It doesn't take any parameters, but let's say you had a POST request and it could take some parameters. So all you have to do is just add parameters here, which will turn out to be query parameters. And then you can add authorization. If, for example, you have a URL which requires authorization, you can add authorization. There are different types of authorization that are available. Till the point open authentication 1.0, so you can use any of the two types of authentication. Then you can modify your HTTP headers also, and then if you want to add body to your request, you can add it here. But in this case, we don't have to add these information because it is a very simple request. So all we have to do is save the request. Now the request has been saved. Now the important point to remember and note here is that we have created an object which can now be used by anyone in your team. So there is a get all books API request. So in the test, which we will see in a moment, people can just reference your get all books object and they can start using it. So they don't have to come back here and create a new request every time. So this allows you to reuse your methods, your objects more frequently as you would in your regular framework. So I will just remove this. Now we just created this request. At the creation time, you can actually verify how the response would look like. So I have just clicked on the green button here, which is the run button, and it will hit the URL it will hit the web service, and it will give you back the response on the right hand panel, which is basically the response section. There are a few important points that you would like to note here. The response section shows you the response in these three formats. At this moment, it is showing it in pretty format. You can look at the headers, and then there is verification log, which I won't cover in this topic. So here in the response, the good thing about Katalon Studio would be that when you hover over the response, if you just move your mouse cursor over the response, you can see that on the left hand side, there is this item that keeps on changing. It is basically the JSON path. So in your response, it actually pinpoints the exact thing that you're looking at. So for example, if I hover my mouse over this ISBN number, so it will say books 0.isbn, which means that this is the exact JSON path to the ISBN number of the first book. You can use these these JSON paths to actually write assertions for your test. For example, I could write a test where I can verify that the first book that is returned to me is has an ISBN of this. We will see how we can add that. So that is one important thing that Katalon Studio provides. Uh, so once you have created an object in your object repository, it's time to add a test case. So all you have to do is just right click on the test case, do a new, and you can use test case. You can even create folders for managing your test properly, but in this case we will just use a test case option. So I will click on it. It will ask me to give a name and a description. So I will just say test to get all books. You can give a better name, of course. You can add a description and tags. The tags uh, is basically you can tag your test case. You can group test case based on tags so that you can search them later given a tag name. So I will just create a test case here. Uh, Now, as soon as I created the test, you would see this small window or a small panel that pops up. This panel looks very similar to an Excel, right? So this panel is useful for people who are not into programming that much. Like your manual tester in your team. If you want to make your manual testers productive as soon as possible, this is the panel that they can use to write tests. I will show you how they can write tests using this panel in a minute. Now, in this mode, you can also go to the script section, which is basically the code part. Here you can write your Groovy tests, Groovy statements, and you can write your test. If uh, you are a automation tester, you know how to code, then you can directly use this section. Uh, so we will come back to our manual section here. So all you have to do now is write your test, like which is like the basic steps that you would do in your test. So the first thing that you would do is basically add the first item in your test which would be making a request, making a call to the web service. So all you have to do is click on add web service keyword. It will give you an option to add a keyword. So in the first item, all you have to do is select the drop down. You will get a lot of options here. So basically these are the keywords which you can use to perform standard actions. So Katalon has already given you these keywords. You can use them to perform very standard actions. For example, send request. This would help you send a request, as the name suggests, and send request and verify. Basically, you send a request and then verify something out of it. And then there are these verify statements, which can help you verify some or all parts of your response. So let us use the first statement, which is send request. Once you do that, you have to fill the object part, which is basically what kind of request you want to send. So when you double click on it, this is the interesting part. When you double click on it, you would get this small window where you will have the object that you created a few seconds ago, right? So here we created a web API request, which was get all books. So it is already available here. If you had multiple requests, you would get all the requests here. So I will just select get all books and I will click on OK. So now it will add a statement in the code which will say that make a call to get all books API. So if you want to quickly take a look, you would see that this is the request statement. This is the request code. So this has a profound impact actually. So for a manual tester who's not into technical coding that much, programming that much, they can write simple statements which are like English-like statements, and the code will be automatically generated for them. This also gives you a benefit that the members who are proficient in coding or who have technical aptitude, they can create objects for the manual testers, and the manual testers can then directly use the objects. So this way you can make your complete team productive without reskilling them or giving them a very little training around this tool. So coming back to the test, once you send the request, you have to specify where to store the request. So in the output section, all you have to do is just name a variable. So I would say books response. Now, once I write this down, you would see that in the script section, now the response of the request would be stored in a variable called books response. You can use this variable throughout in your test case to perform other actions. We will see it in a minute. So once you have your books response, you can add a description here in the end, so that later on it makes sense when you read the test case. So once you have the books response, you can add assertions now. So assertions or verification statements, and you can verify the response. So I will quickly add another step into the test case, and in this step I will simply say uh, we will verify something. Let us verify uh, the status code, the response status code. So I will select the keyword verify response status code, and then in the input section, it will ask me to give the response object, which in this case, all I have to do is it's a variable, and the variable name was books response. And in the books response, I'm expecting a status code of 200 because it's a success response. I won't be getting into technical details of what a response is. I am assuming that most of us are already familiar with that, uh, because it's too short a time to cover everything. So we will give the expected response and click on OK. Now here you would see that this statement has been added, but in the script you can see that a verify statement is added. Now this verification statement will basically be your test. So now that we have added a verification statement, let us quickly see how it runs. So I will save the test, and there is this small run button. All you have to do is just click on it, and you will see that now the test case, the test is being picked up by the runner, and you can see that it ran the test. And here you can see that the request was successful. You click on the request, and you can see more details about it. And then you can also see the next step, which is verify response status code, and it will say that response status code was successful. So this is how uh, you can run a test. And the important part is that the reporting is automatically generated for you at the bottom. There are other reports on the left hand side. We will see that how they are generated in a minute. But you can see that it gives you a very tabular structured format. You don't have to write all the boilerplate code to get this format of reporting in your framework. It is just by default that comes up with the tool. Now, we will quickly add another assertion here, and we would simply say that I want to verify something in the response also. So I would say verify element property value. Uh, yeah, and here I will specify that I want you to verify in the response object. I want you to verify uh, string at a particular location. So we talked about the JSON path, right? So is all I have to give here is the JSON path. So I will simply say books 0.isbn. So this was here. It means that the 0th book in the response. Can you verify the ISBN number of the book? And to which what is the value that I want to compare it with? I would simply say I want to compare it with a string value, and let's just give it a random number for the time being, and I will say okay. So now it will create an assertion step here for you. It is very easy for manual testers to quickly understand this, and for advanced user they can go back to the script, and in the script there is automatically code generated for your statement that you just wrote in the manual mode. So now we can run the test again, and we will see what happens. So you can see that it has started with the first step, which is sending request. It was able to successfully do it. Then response code was also verified, and it was true. It was successful in that. And then while verifying the element, there was some problem because everything is red right now. So in the response section, if we just move it here, you can see that it will clearly specify what kind of failure happened. So here it says that in the book's response, uh, this verify statement failed. And somewhere here, you would see that expected element property value was this, but the actual property value was this. So all the code that you would eventually write when you create your own framework to get such kind of reporting and everything, that is already present in Katalon. So that can help you speed up your development cycle. Now, uh, with this test creation, let us move on to the final part of it, which is creating a test suite out of all your tests. At this moment, we just have one test, so I will simply say that I want to create a test suite out of it. So I will simply say test suite, new. I will create a test suite. I will say uh, books API store, let's say, and we can add a description, of course. I will click on OK, and here it will give me a small UI which can help me add tests here. So all I have to do is just click on add. And when you add, you can see that all the tests that you have created, they will be listed down here. You can select the ones that you want. In this case, we just have one. So I will select this and click on OK. And there you go. So the test has been added to the suite. So you have successfully created a test suite, which is basically some task when you do it yourself in your framework. So here you get it very quickly with just a few clicks. All the boilerplate code, it has already been taken care of by Katalon. So all you have to do is now is that you can just do select this, and you can select the test suite that you want to run and click on run here. Once you run it, it runs the test suite and basically just generates a report out for you. So it has run the test now, and you will see that in the reports folder, you will have a report already present. So just click on the report. It will give you a report with a timestamp. Just click on it, and there you go. So this is the kind of report that you get. So everything from writing tests to creating test suites to getting the results, it is basically inbuilt. It is pre-built for you. You can customize it based on your needs, but it is already there for you. So here you have the test result. It gives pretty decent information right now. Uh, all the information that you would need, including maybe including the exception that you got. So this is how Katalon Studio can help you achieve your API testing quickly, efficiently, and can help your staff members who are not into programming contribute in your API testing efforts. So that was pretty much it from the demo perspective of Katalon. Can we get back to the slides?
Thanks, Virendra. Yeah, absolutely.
Yeah.
Let me go ahead and share my screen so that way we are back on the wrap up. I know we are running a little behind time, so we'll hopefully wrap this up fairly quickly. Are you seeing my screen, Virendra?
Yes, yes. So yeah, I will just quickly wrap up around these two slides. So we talked about benefits of Katalon Studio in details in the demo. So these are the lists of other items that you would find really helpful to choose between what framework that you want to use. So Katalon Studio, it already supports REST and SOAP-based web services. Uh, it can help you write test. It's a all-in-one shop for API, web UI, mobile testing needs. So you can just use anything, create any kind of project that you need. There is a facility of code inspection, which constantly monitors your input for correction. It will give you suggestions, and as we saw, that it will automatically generate code for you. Then we have in Katalon Studio, the important feature that we also discussed in the trends is that it has integration with all the with the CI tools and the other tools like Jira and Git, which is like Git is um, uh, your place where you would store your code, and Jira would be your tool where you would manage your bugs and your tasks. So it has all the integration already done for you. Moving on to the next slide. This is a quick look at what is the market position of Katalon. It is a quick comparison between the five important tools that are available in the market. So you can just take a look at it. This is the source from where this information has been taken. It details out like why Katalon Studio is at a position where it is right now. So we just saw the capabilities of Katalon, and this is the market comparison. I think that's pretty much it from my side.
Gotcha. Thanks, Virendra. Thank you, everyone, for attending. Unfortunately, we're out of time, which is why we will not be able to go into the Q&A section. But I did notice a lot of the members who were listening in were already answering each other's questions as part of the chat room. But what I would encourage the participants who do have questions to post them in the community and the blog sections for Katalon on Katalon's website, or post them out to the emails on the Katalon website, and Virendra and I will try to answer them as soon as they come in. Again, thank you everybody for attending, and we hope this session was beneficial for you, and you guys feel confident you can now go and try Katalon and perform API testing with. All right, thank you so much. Bye-bye.
Thank you. Thank you for joining in. Thanks.